Excellent. Hello, everyone. I'm Lawrence Freidl. I'm the director of the Applied Sciences program. This whole week, we are hearing all about these great benefits and the great new knowledge that's coming from all the research. There's also a dedicated program within NASA Earth Science that's also trying to see how do we extend and how do we get some of the more immediate, practical, and innovative applications from what's going on, what we're learning from the research. And that's really what we wanted to talk about. Now, we're in Louisiana, and so we wanted to talk about something that happened in August of 2016. This is a story about a woman named Ginger Whoville. And so here in the Louisiana area, in August of 2016, there was a major sort of extreme event, and it was right in here, just to the west of New Orleans. And that is where Ginger Whoville's living, right in here in the town of Watson. It's in Watson, Louisiana. And that's where she and her family were living. Over 31 inches of rain fell in a very, very short time frame. And so she and her family actually had to escape up to their attic. She described it afterwards as saying that it was like they had several fire hoses directing the water right into their house. And so the water was really, really rising. Now, NASA, because we have an organized disasters program, and a number of other agencies as well, were involved in helping FEMA understand the extent of this. And so there were state, local, federal, a lot of different organizations who were involved in helping the town of Watson and the broader area understand just how much water there was. And so there was lots of different rescue efforts. Part of it was the fact that because it was raining, you cannot see it with the general optical imaging satellites. And so because we had the relationship set up with the Europeans, and in this case, JAXA and ALOS-2 data with the Japanese, we're able to get that data and help identify the extent of the flooding. As well as there was also other agencies were doing airborne to fly underneath the clouds to get the extent. Originally, FEMA had estimated they were going to need about 24,000 mobile homes to satisfy the need. After they got the data from NASA and NOAA and from other agencies, they realized that they were off by a factor of 2. So they almost doubled their order of mobile homes. And so this is what Ginger's house looked like when she was finally able to get back to it. And so it was nothing that she could stay in. And so that's actually an image of the trailer that Ginger and her family were received from FEMA. And so she was ecstatic that she's been so blessed by having this trailer. And that's sort of the impact that she may not realize that Earth observations and all the Earth science data and all the products that are coming off of these satellites were involved in helping make sure that she had a trailer. But that's the sort of impact that Earth science and Earth science data can have. So within the Applied Sciences program, a lot of it is trying to see how do we help extend that data products. And a big thing is helping our organizations even understand how they can be using those information products in their decision making and all. I think the second thing that I think is a really key part of this is understanding that event in Louisiana and helping FEMA understand how to use that data was not something that was done in real time. That took years of relationship building with FEMA to help them understand what data existed. It helped them understand where to be getting it. And all that relationship building happened in the years preceding events like that. And so I think that's a key part of what we're doing in NASA Earth Science, and especially in the Applied Sciences program, where we're trying to understand what's the research showing, but it's also what are those user organizations, what are those managers sort of seeing, and how is it that they like to receive information? What are the data formats that they even like to receive it in? What are their trusted sources of where they even go to get the data for that? And so we have a couple different aspects of the program. You can see the themes that we have. But in addition to supporting applications, we're also trying to see how do we build out the workforce? How do we help support international development efforts? And how is it that we can get applications, anticipate applications sooner in the mission life cycle so that those benefits can accrue to society sooner after launch? So one question I have, on a per capita basis, who here knows what state in the US has the highest incidence of West Nile virus? You've already guessed, it's South Dakota. Very good, you all can read. I clicked this too fast. Anyway, so this is with the South Dakota Department of Health and South Dakota State University have worked out this system and using NDVI as well as GPM precipitation and other data products to help them get a sense of where the environmental conditions are right, where you're going to be getting mosquito outbreaks. And that is going to be related to West Nile virus. And so in 2015, there was actually a really, really bad outbreak, extremely high. It looked like 2017 was going to be a bad year as well. But then about midway through the year, using the satellite data and all, and using some of the modeling activities, they realized it wasn't going to be as bad as they thought. And so they're putting out the West Nile Weekly, and they're putting out essentially information so that the managers, the public health managers, can help the towns understand where they need to be doing spraying and all to help support public health. Now, there's a great video about this. So I want you to go to YouTube and just, on YouTube, search for Modus meets mosquitoes. And there's a great 5-minute video or something describing all this with some testimonials from people from the South Dakota Department of Health. And so Modus meets mosquitoes. So some of our work is not just domestically. A lot of it is in the US. There's also a lot that we're doing internationally. And so tea, after water, tea is the most popular beverage worldwide. And so the next time that you all have a cup of tea, I want you to think about the fact that there's a pretty strong chance that that tea came from Kenya. Kenya is the 3rd largest producer of tea worldwide, as well as about 10% of the Kenyan population, about 4 million people, work in the tea industry. So this is a pretty big, actually, the tea and the coffee industry in Kenya. So it's a pretty big deal because one issue that they're affected by is frost. And so because it's such a large part of their industry, large lot of their economy, Kenya has invested a lot in doing sophisticated farming techniques. But up to a few years ago, they had no way of detecting frost, and frost can just be a killer on some of these crops that they have, and the tea crops. And so thanks to a program that NASA's doing in in cooperation with the U.S. Agency for International Development, USAID, there's a joint effort to create frost occurrences. And so with about a 72-hour warning, the farmers can understand where they're going to be having frost conditions so they can take steps like irrigating their fields and doing other things to reduce or eliminate the damage from that. And that's a key thing when, for the amount of money that the farmers are getting, it's about $1,200 a year. And so from that standpoint, taking steps that may only be $80 to protect your entire crop is essentially going to be protecting your entire income for the year. So that's a key aspect. The other thing that we didn't quite see when we first started on this project was the fact that it's not just the farmers, it's the insurance companies. They've started using this tool to help identify where there were frost conditions, so when they have insurance claims coming in, they can use this product to determine whether these claims are legitimate or whether they may be sort of false claims. And so it's really something that they can sort of see whether there's negligence involved, or they can really sort of assess these claims. And so there's this broader effort that we have. In addition, one other aspect of using the earth science data is looking at the efficacy of some of the policies that our government and other governments pursue. So in this case, this is an image of the US back in the 2005 timeframe. This is looking at nitrogen dioxide, certainly an indicator of human activity from combustion and burning and all. And so this is what it was in 2005, about the same time that EPA issued the Clean Air Interstate Rule. It was later updated to 2011. And so this is really to reduce power plant emissions. The big factor was the fact that a lot of the power plants in the east were actually the pollution was transporting eastward. And so the states on the eastern shore, on the eastern, the Atlantic coastline were having trouble meeting the air quality standards, not because of what they were doing in their state to do air quality control, but because of what was being transported in. So, jump ahead to 2014, and we're going to be able to sort of see the effect. So you can see 2005 when they instituted this Clean Air Interstate Rule to 2014. So this is after the Great Recession. This is increased population, increased vehicle traffic, and you can still see the effects. I realize there's many factors beyond just the rulemaking, but there's a key dramatic way for satellites to help indicate the efficacy of that policy. And it was actually in 2016, for the first time ever, that US EPA included satellite data in their air trends report. So that's also a nice indication that another agency is recognizing the value of the satellite data to help tell the story about what's going on with air quality. So there's all these different ways of looking at this. One thing we did want to tell you about is a program we have called Early Adopters. And so we recognize that if we can, with any new future satellite missions, if we can anticipate what those applications might be, if we can do that in the pre-phase A or the phase and phase B, phase A, phase B timeframe, and we can be anticipating what some data formats might be to help it be more used by the people out beyond the research community, then as soon as those data is available after launch, that benefits the society from using the data in that decision making, whether it's public sector or like other government agencies, or private sector, especially with companies or NGOs. That can be a key way for us to maximize the benefits that are coming from our major investments in these Earth science satellites. You can see here are just a number of the early adopters that we currently have on some of the current missions: SMAP, ISAT-2, TEMPO, NISAR, SWAT. So a lot of the missions that we have that are either up there now or the ones that are in formulation and development are starting to have these early adopter programs. So anyway, thank you very much. Wanted to just sort of leave you with a few quotations that people have sort of said, organizations that have been using the Earth science data. Wanted to leave you to read these to get a sense of the fact there's a lot of people out there, a lot of organizations beyond the Earth science community, who are really valuing the fact that the research you all are doing, the data products you all are producing, the information products that we're getting out there, people are really valuing that. So thank you very much for everything you're doing. We're looking forward to hearing about what's the latest this week.